Hello, we are team number 6 and I'll introduce our project proposal, detection of gray point based on MASC-R CNN. According to OECD, the world's discarded plastics are recycled only less than 10% of them. On the other hand, the amount of waste thrown away is increasing year by year. And also, according to the OECD's Global Plastics Prospect Report released in 2022, about 460 million tons of plastic were used in 2019, which has nearly doubled since 2000. In addition, after the coronavirus crisis, the number of recycled plastics has increased dramatically. The amount of waste exceeds the capacity of the workers of garbage sorting facilities, and our team thinks that robots can be used to resolve this problem. Our team divided the problems into two parts: object recognition and classification through images, and detection of the grasping point and carrying the object. This is the overall plans of our team in detail. First, use the MASC-R CNN and UNet parallelly to remove the noise and use fully convolutional network to distinguish object in detail. Next, to find the grid point, compute the center of the grid point, angle and width of grid area using result of previous neural network. And then we have to consider the coordinate of manipulator, object, and images to pick an object properly. Lastly, using the inverse kinetics, compute the angle of each motor of manipulator, and then transfer the object to appropriate place. Now I'll introduce the details and predicted difficulties of each steps. We will use two neural networks, MASC-R CNN and UNet parallelly. MASC-R CNN is used to compute width and z coordinate and mask for noise removing. UNet is used to compute x, y coordinate and angle. In this step, we'll use more 3D-like object than the reference, which means that bigger variations in z coordinate. So we think that there may be difficulties in estimating depth with single camera, and it causes different results from the reference. Also, we have to consider the lens distortion, which makes the edge of images twisted. In coordinate translation step, we set the each coordinate of manipulator, object, sensor by using calculated angle previously, and translate the all coordinate to the manipulator coordinate to calculate possible move of the gripper. We also consider the lens distortion in this step 2 and camera calibration. Lastly, in pick and place step, calculate proper motor angle and grip the object using inverse kinetics. Then, place the object to a fixed area with respect to the class of object which is determined in image processing step. We have to solve the dropping object problem while moving and decide the criteria for selecting the order of gripping object to carry. Also, handling the case in which the object is overlapped might be our challenge in this project. Similar study was done in 2019. In this study, they used Kinect depth camera combined MASC-R CNN and UNet and inverse kinetics to control robot. Using this, they can detect and grasp various kinds of plates with about 90 accuracy. Finally, I'll introduce some main technologies used in our final project. UNet is an end-to-end convolutional network proposed for biomedical image segmentation. The network is consisted of contracting path and expanding path, which makes network U-shaped architecture. The contracting path is for capturing the context and consists of repeated application of convolutions, ReLU, and max pooling operation. And expanding path is for computing the segmentation map by combining the feature and spatial information through a sequence of convolutions, and concatenations with high-resolution features from the contracting path. It also uses ski connection to exploit information from lower-level layer. Next technology is mask RCNN, which is successor of faster RCNN. It uses to detect and classify each object and generates masking. It classifies objects using feature map and it is calculated from region of interest ROI. Beside pictures shows the result of the images which is passed through the mask RCNN network. To sum up, our project can be simplified into 4 steps: image segmentation, grid point computation, task manager, inverse kinetics. Thank you for listening.